Today we are going to discuss angles of depression and angles of elevation, and use tangent and arctangent to calculate angles of depression and elevation. Let's get started. Angle of depression. The angle of depression is the angle that is formed between the horizontal and the downward-looking angle. It is always a downward view, an angle below the horizon. A line of sight is a sight line from an observer's eyes to the object being observed. You can look up, look straight ahead, or look down. A horizontal line is a line viewed straight in front of you, with your eyes neither looking up or looking down. You are looking to the horizon. Let's look at an example. An Airbus A380 commercial airliner places the pilot's cockpit window at an astounding 7.13 meters above the ground. From the cockpit, the pilot looks down to the airport tarmac and must be able to see the airport crew members giving visual signals. For the ground crew member, looking down would not be much help in communicating with the pilot in her cockpit seat, so the crew member will look up, above the horizontal line to see the pilot. The ground crew member's angle of vision is an angle of elevation, the angle above the horizon. For both people's viewpoints, the pilot's eyes in her cockpit seat 7.13 meters above the tarmac, and the ground crew member's eyes roughly 1.7 meters above the tarmac. Both angles are the same. Take a look at the sketch. Notice the angle of depression is the same as the angle of elevation. Since the horizontal lines are parallel, this is a case of alternate interior angles created by a transversal, which is the line of sight cutting across two parallel lines, or the horizontal sight lines of each person. The angle of depression provides important information about distance and height. Recall the three trigonometric ratios or identities: sine, cosine, and tangent. They each are the mathematical relationship between angles and sides and the hypotenuse of a right triangle. Sine x equals opposite side to the given angle divided by hypotenuse. Cosine x equals adjacent side to the given angle divided by hypotenuse. Tangent x equals opposite side to the given angle divided by adjacent side. If you know the tangent of an unknown angle, using the tangent formula, you can use the inverse of tangent, arctangent, to find the actual angle. Let's look again at our pilot and ground crew member. We can create a right triangle with the pilot at the top of the short side, the crew member at the far end of the long side, and a hypotenuse, the line of sight stretching between them. The long side is the ground crew member's horizontal line. The short side is the right angle straight up to the pilot. The height from the crew member's horizontal line to the pilot's eyes is our opposite side, and the adjacent side is the distance from that side to the ground crew member. We know the height of the opposite side from basic subtraction of the pilot's and ground crew member's eye position above the tarmac. 7.13 meters minus 1.7 meters equals 5.43 meters. The ground crew member stands far enough away from the aircraft to see the pilot and be seen by her. Let's call that 25 meters, the length of the triangle's long side. We know the opposite side and adjacent side measurements, so we can find the tangent of the angle of depression for the pilot and angle of elevation for the crew member. They are the same number. Setting up to find the tangent allows us to find the inverse, the angle itself, using arctangent. First, we find tangent using our formula. Tangent equals the opposite side divided by adjacent side. So we have tangent equals 5.43 divided by 25. Inverse of tangent to find the angle. Arctangent, 5.43 divided by 25 equals arctangent 543 divided by 2,500, which equals 12.25 degrees. The pilot is having to look down only 12.25 degrees below horizontal, and the ground crew member is looking up only 12.25 degrees above horizontal to see each other. If you know the angle of depression or elevation, you can calculate distances, either height or length, using tangent. If you know the heights and lengths of the two legs of the right triangle, you can calculate the angle of depression or elevation using the inverse of tangent, arctangent.